So today we will study about downy mildew of grapes. Downy mildew of grapes is one of the most destructive disease of grapevines. Now we will study about its history. Prior to 1870, the disease was endemic in North America. From America, it was introduced into France when actually resistant grapevines were brought from North America to France against aphids. So during that, the disease was introduced in the France, and in the year 1875, it has caused epidemic in France. So it was in search of chemical control of this disease to save vineyard plantations that Professor Millardet, P.A. Millardet of Bordeaux University made accidental discovery of Bordeaux mixture in the year 1885. Now, this is about its further spread. Its incidence was recorded, and its severity as well as its spread was occurred in England in the year 1894, in Brazil in the year 1893, in South Africa and in Australia respectively in the year 1907 and 1916. In India, the disease is prevalent in Maharashtra. Crop losses due to downy mildew may vary from 50 to 100%. Losses mainly occurs due to damage of foliage. That is, damage of foliage will also lead to what? It will damage the photosynthetic area. So that is the reason of main losses which occurs in grapevine plants due to this disease. Now this is the symptom. So we will study now about symptom. Symptoms appears on aerial parts and tender parts of the vines. They are more pronounced on leaves, young shoots, and immature berries. On the upper surface of leaves, irregular light yellow spots are seen. On the opposite surface, below these spots, downy growth of the fungus may be present. See here, the downy growth of the fungus are observed, and on the upper surface, we are seeing yellow spots. Later, due to necrosis, these leaf spots turn dark brown. Growth on the lower surface becomes dirty gray. Number of spots may collapse to form large necrotic patches. Infection of aged leaves results in mosaic type of symptoms, development of mosaic or smaller angular yellowish to reddish brown lesions limited by veinlets. Affected leaves may fall prematurely. So then what can happen? The disease shoots remains stunted due to that may be, and maybe swollen also. They may be swollen also, and this is due to hypertrophy. Nodes of the plants are more susceptible than the internodes. Infected leaves, shoots, and tendrils becomes covered with whitish growth of the fungus. Flower and young berries are also infected. Infected inflorescence first turns oily, yellowish brown, and may develop downy growth during periods of high humidity. Infection of berries occurs in early stage of their development. Fungal growth is visible on the surface. Sometimes we can see the fungal growth on berries also. Now, this is the causal organism Plasmoptera viticola. So, we all know this one is the asexual stage of the fungus Plasmoptera viticola. Here we are observing sporangiophores are there and many sporangia are there. So, sporangiophores arises from hypha. 1 to 20 sporangiophores emerges from a single stoma, and the branching here, that is very important. The branching of the sporangiophores is almost at right angle to the main axis at regular intervals. This is the actually characteristics to identify the Plasmoptera species or Plasmoptera viticola. The sporangia are hyaline, thin-walled, ovoid or lemon-shaped. This is an ovoid or lemon-shaped sporangia we will find, which may be papillate actually. And within this sporangia, we will have zoospores. Zoospores are pear-shaped, having two apical flagella. Now, in its sexual stage, the fungus produces oospore. Oospores are produced mostly in tissues adjacent to the midrib of the leaf. They are thick and wrinkled walled. So now we will learn about disease cycle. So here what happens, this is we are observing antheridium, that is male gametangium, and that is oogonium, that is female gametangium. So they will form the oospores, and this is the oospores, and oospores will they serve as the mode of the fungus for pollination. Okay, so the primary source of inoculum actually of the fungus is soil-borne inoculum, and the oospores serves the purpose. So from the oospores, sporangium is produced. Sporangiums, this, and in this sporangium we will have many of zoospores having flagella, two flagella. These zoospores, then they will in fact they will insist and enter through stomata, and they will form germ tube, and they will penetrate, and then they will form we will see the development of the symptoms on leaves and berries. Here fruit infection also is observed on leaves also. Then again this cycle will may continue, that the zoospores, that is zoospores will again infect a new plants, and this is your secondary infection, or it can again go, and it can go for over this one to form oospore, and again in next season it will act as a primary source of inoculum. So this is about disease cycle. Now this one is about management. We have to follow proper sanitation measures. Affected or fallen leaves and twigs are to be collected and destroyed, as they will serve as the primary source of inoculum. Ensure free circulation of air and low humidity. So we have to ensure free circulation of air and low humidity, and we should also maintain optimum spacing. And there are some varieties in South India which are found to be resistant, namely Amber Queen, Cardinal, Champa, Champion, Red Sultana. Then about copper-based products are effective, but for choosing fungicides we have to be very much selective, and the fungicides which are actually recommended by the government, only those we have to use.